Okay, so when you talk about adding and subtracting polynomials, I think the first question we should probably answer is, what's a polynomial? Any guesses? Any brilliant ideas on what a polynomial is?
Really complicated math equation.
It's actually not that complicated. The book definition is that it is a sum of terms in the form ax to the nth power, where a is a real number and a is a real number, n is a whole number. I want to say, which is, I think, just a superb definition that absolutely tells you what a polynomial is. Just kidding. That definition's terrible. I think the best way to understand what a polynomial is to see what some of them look like. So here's one. That is a polynomial. Specifically, that is a kind of polynomial called a binomial. And it's called a binomial because it has two terms in it. Oh, great, more vocabulary. So,
plus in between 4x squared?
Are you making fun of my handwriting?
I thought it was an R, to be honest. I thought it was an R.
My one weakness, plus signs, and you have to call me out. That's messed up. Anyway, as two terms, okay, so follow-up question, what's a term? So terms are separated by plus and minus signs. It's basically a term is a number, or sometimes it's a number and a variable that are raised to some power. So this right here is a term, and this right here is a term, and they're separated by a plus sign. So two terms make something a binomial. Okay?
Polynomials 1 and binomials 2.
No, polynomial is all of them. They're all called polynomials. These are just specific kinds. Now, if you had to guess, what would you say the name of that guy is?
Trinomial?
That's a trinomial because it has how many terms? 3 terms. Good. What are they? What are the 3 terms? 9x to the 4th is 1. Negative 7x is 1. And negative 1. You include the negatives. Okay, how about this? What do you think that one's called?
Single nomial.
Polynomial?
They're all polynomials. So this one's a kind of polynomial. How many terms does it have? Just the one. Any guesses? What?
Unomial?
Uno-nomial? How dare you, sir? Uno-nomial. It's not Spanish, it's Greek. Monomial.
Mono, like monoplane and biplane.
This is the polynomial you get from too much smooching. Monomial. All of these are called polynomial. After 3 terms, we don't really have any special names for them. So like if I gave you some kind of crazy, like 10x to the 5th minus 7x squared plus 2x minus 4, we don't really have a special name for those, like a quadrinomial or anything. We would just call this a polynomial. I'm sure somebody out there has prefixes for however many terms there are, but we don't get that fancy. Monomial, binomial, trinomial, anything above that we just call a polynomial, but all of them are polynomials. Poly means many, and nomial means probably name, I'm guessing, but I don't know. I don't speak Greek. Probably name. You know what? If I hadn't said probably, you all would have believed me. Poly means many, and nomial is the Greek root word nomial, meaning term. Yep, looks like everybody's buying it. Perfect. Perfect. So one of the things you need to know about polynomials is how to classify them. And when I say classify them, I just mean, is it a binomial, trinomial, monomial, or none of the above? The other thing you need to be familiar with before we get into this is how to find what is called the degree of a polynomial. Oops, that's an A. A polynomial. Okay, you can make fun of my handwriting on that one. That was a pretty bad A. Cool. So degree. The degree of a polynomial is the sum of the exponents on the variables. So that is a fancy way of saying the degree of a polynomial means you add up all of the exponents. This is going to be relevant to us in a minute when we start adding and subtracting them, because in order to add and subtract polynomials, they must have the same degree. So being able to tell what the degree is going to be really important to us. So let's start off with an easy one. This one only has one variable. What's the variable? X, and the exponent on that variable is a 2. So we would say that this is a second degree polynomial, but we can be even more specific than that. What kind of polynomial is it? How many terms did it have? 1, so a second degree monomial. Yeah. That's kind of handy. All right. All right, I'm trying to trick you. Any guesses?
1 or 2?
2 to the third, x to the fifth. What's the degree?
Third degree.
Second.
2 or 4, because the negative's got to be included, right? No, 3.
Read the definition again.
It's 2.
Then it's 2, yeah, 2.
Sum of the exponents on the variables. It's 5. Very good. 5 variables only.
Oh.
So this is a fifth degree, also a monomial. I'm going to give you all monomials here first. Monomial.
Wait, why is that 5? Is that a 3 and a 5?
Yeah, it's 3 and 5, but look at the definition. Sum of the exponents on the variables. 2 is not a variable.
Okay.
So we only look at the x. Okay?
So,
What's the degree of that one?
1.
1. So that's first degree. I'm not going to keep writing monomial because they're all monomials. That one is first degree. All right?
Five.
6. What's the exponent on the x?
2.
Plus the exponent on the y?
1.
Plus the exponent on the z. So this is 6th degree. Sixth degree polynomial. 2 plus 1 plus 3. Look Who's Talking 2, starring John Travolta and Kelly Preston. Kelly Preston was in The Invisible Man with who? Kevin Bacon. 6 degrees. What about that one? Yeah, none. So what's the degree?
0.
It's the 0 or 0th degree because there are no variables. A 0 degree polynomial. There kind of is a variable here. It's just hidden. This would be 5x to the 0 power because anything raised to the power of 0 is 1. So this is 5 times 1. So that's why it's just 5. So kind of it's there, but we don't write it. Okay? So what about when you've got a bunch of terms like this? So when you have multiple terms like you do in this one, and you're finding the degree of the polynomial, the degree is the highest of the sum of the exponents. So if we look at these terms one at a time, this one right here, this first term, what's the degree? 2. What about this one? 1. And this one? 0, because there's no variables. So the highest we had was 2. So this would be a second degree. What kind of polynomial?
Mono.
Trinomial. Good. Because it'll try anything. What do you think? What's the degree of this one?
1.
1. And the degree of this one? So the highest is, so it is a
Mono.
first degree. How many terms?
1.
1?
Technically 2.
It's got 2, yeah.
Oh.
Not technically, it just has 2. First degree binomial. Okay, what's the degree of the first term? 1. The degree of the second term?
3.
What's the degree of the third term?
2.
And the degree of the last term?
0.
So the highest was 3, so that makes it a third degree. How many terms did we have?
4.
We had 4 terms. We don't have special names for them.
Polynomial?
So it's just polynomial. Yeah, good. We don't have special names after 3. Great. Now the last thing we need to talk about is something we've been avoiding, and that is what is called the numerical coefficient. I've used the word coefficient quite a bit this semester. Do you have any idea what I mean when I say coefficient, or have you just been sitting there quietly every time I say it hoping that someone else asks? Yeah, there you go. Honesty. Any ideas what a coefficient is?
Like a substitution?
Oh, 30.
It's much easier than that.
It's division, right?
Coefficient is the number in front. That was going to be your next guess, right?
Yeah.
It's the number in front. So let me give you a polynomial here. That's a doozy. That is a doozy, as the kids say. So this one obviously is a polynomial because it has a bunch of terms. How many terms does it have?
7.
The way you can tell if something is a term is, are they separated by pluses and minuses? So here's a minus. That means this is a term and this is a term. There's a plus sign separating the next set. There's a minus sign and there's a plus sign. Now notice when I was identifying those that if there was a minus in front of it, I included the minus in my bracket, and that's because the minuses matter. If it has a minus sign, then we treat it like a negative. So let's do these one at a time. Take a look at this first term here, 7x squared y. What is the numerical coefficient? I'm going to abbreviate that NC. The numerical coefficient is 7. That's the number in front. And the degree is
2.
it's 3. 2 on the x and 1 on the y for a total of 3. Good. Okay, what about this one? Negative 6xy. What's the numerical coefficient? Be careful. What's the number in front?
Negative 6.
Negative 6. And what's the degree?
2.
2. Good. Okay, what about our boy x squared. The numerical coefficient is
1.
1. If there was a 0 in front, I heard somebody whisper 0. If there was a 0 in front, it'd be 0 times x squared, which is 0. This is 1 times x squared, which is x squared. What's the degree? 2. Okay. What about the next one? Negative 3y. What's the numerical coefficient? Negative 3. And what is the degree? 1. Perfect. And finally, the plus 7. What's the numerical coefficient?
7.
It's 7. And what's the degree?
0.
0. Great. So far, so good? Okay. We're getting close to the addition and subtraction, I promise. We're just learning about polynomials, though. Let's talk about something called a polynomial function. I love polynomial functions. They're really easy, but they look like you'd have to be a genius to do them, and that's sort of right in my wheelhouse. Things that are easy but look like they're insanely hard. That's how you impress the kids at the math party. So you have been dealing with so far tonight, dealing with what are called polynomial expressions. A polynomial function looks very, very similar with one minor little change here.
Did you say polynomial expressions?
Yes. Polynomial expression is what it is when it doesn't have the equal sign like I just put in here.
Okay.
Equal sign makes it a polynomial equation, and the px there in front is what makes it a polynomial function. So this right here is a little confusing because it looks like it's p times x, right? So p with the x looks like p times x. But this is a special symbol that does not mean p times x. It's what makes it a polynomial function. And the way you read this is p of x. This is sometimes referred to as function notation. Function notation is good stuff. So here's what function notation does for us. Here's what we gain with function notation. The only thing we're going to do with polynomial functions in this class is solve them for a certain value of x. Like I'll say, what if x was 3? What would this equal? And you plug it in. That's all we're going to do in this class. The way that that looks is like this. Now what this means in English is replace, or if you wanted to use your official math vocabulary, and you do, substitute 1 for x. It means I'm going to write that function, 3x squared minus 2x minus 5, exactly as it's written, but all of the x's are going to be substituted with the number that was in the parentheses, which is 1. So here's what that looks like. Instead of p of x, it's going to be p of 1. So instead of 3 times x squared, it's going to be 3 times 1 squared minus 2 times 1 minus 5. That's all it means. All it means is replace the x with whatever that number in parentheses is. The math here is very simple as long as you remember your Dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. So the parentheses aren't helpful because all that's in parentheses is the 1. Let's do the exponents. 1 squared is, so this is going to be 3 times 1 minus 2 times 1 minus 5. Exponents first. Then Aunt Sally says to multiply. That's really easy because it's all times 1. So 3 times 1 minus 2 times 1 minus 5. And then we just do subtraction. 3 minus 2 is 1. And 1 minus 5 is negative 4. So the solution here is that p of 1 is equal to negative 4. If you were going to graph this, and we aren't, but if you were going to graph this, the coordinate for this point would be 1, negative 4. We will not be graphing polynomials in this semester, but in the next semester we will. So there's your little preview of all the excitement that is to come. One of the advantages of this function notation is that if I want you to do this again with a different number, I don't have to rewrite the equation. I just say that. I'm like, oh, now do p of negative 2. That means take the p function and replace all the x's with negative 2. Now, at a higher level type of problem, you might have multiple functions. You might have a p of x, like I gave you, and then also an s of x and an r of x. And that letter right in front would tell you which of the functions to use. So it's handy when you have a couple of functions that you're going to use a bunch of times, like you would if you were graphing. If you were graphing, you'd do it a bunch of times. So let's do this again. P of negative 2. And I'm going to write my p function, but replace all the x's with negative 2. So 3 times negative 2 squared minus 2 times negative 2 minus 5. And as long as you follow your dear Aunt Sally's rules, you are going to be okay on these problems. It's just arithmetic. You can handle it. I have faith in you. Ish. All right, so let's do it. Negative 2 squared is 4. So exponents first. Then we multiply. 3 times 4 gives us 12. Now be careful here. It's minus 2 times negative 2.
So that would mean it turns so positive.
Good. So plus 4 minus times a negative is positive. Minus 5. 12 plus 4 is 16. And 16 minus 5 is 11. So p of negative 2 equals 11 is the answer. If you were going to graph it, and to reiterate, we are not, but I want you to see this for next semester. If you were going to graph it, the point you would graph would be negative 2, 11. So I now have 2 points, 1, negative 4, and negative 2, 11. I've got 2 points I could use in order to graph this if I was gonna. And soon enough you will. So let me give you an application of this function notation. I'm going to show you a somewhat common equation. If you've been taking a bunch of science classes, you've seen this. You seen that before?
Microbiology.
What does it do?
Measurements.
Okay, but what specifically is this measuring?
Trying to measure your cells or whatever you're trying to.
Mostly the plus 592.1 is probably meaningless to you. I'm curious, the negative 16t squared. Have you seen that before? That is pretty common. It is a function that represents the effect of gravity. Negative 16t squared. So what this function is saying is, I am holding an object 592.1 feet off the ground, and I drop it. Where is it after a certain amount of time? So if I drop an object After 1 second, it's still pretty close to the top of the building. After 6 seconds, it's probably closer to the bottom of the building. We assume it's falling. After 6 seconds, maybe it's on the ground, right? After 30 seconds, it's probably on the ground, right? When does it actually hit the ground? So let's answer my original question, where is it after 1 second? The way that I would write this is P of 1. So that'd be negative 16 times 1 squared plus 592.1. Now I know it's going down, that's what the negative is, it's falling. So that'd be 16 times 1 plus 592.1. So P of 1 is 16 plus 592.1, which is 608.1. Oops, lost my negative. Which is, yeah, you could tell immediately that I made a mistake. How can we tell right away that I made a mistake? Yeah, but how did we know that 608.1 could not possibly have been the right answer?
It's over the.
Yeah.
You should be removing.
But at 592 when I drop it, it's probably not going to go up, we assume. Unless I'm dropping it in a wind tunnel, maybe.
So it is 576.1.
Okay, where is it after 6 seconds? So negative 16 times 6 squared plus 592.1. So that's negative 16. 6 squared is 36. 16 times 36 is a much larger number. That's negative 576. So we know this is going to be very close to the ground. So P of 6 is equal to 16.1. So after 6 seconds, it's only 16.1 feet off the ground. That means at 7 seconds, what answer would I get? If I plugged in 7, what answer would I get?
Probably the impact.
Yeah, it actually probably would be negative. I'd probably get a negative number if I plugged in 7. What would it mean if I plugged in 7 and got a negative number?
And it's still for a while.
Yeah, it means it hit the ground and it's still or else the ground's super soft and the thing I dropped went through it. It's below the ground. Probably means it hit the ground and stopped and it's been sitting there a while. That's exactly right.
So this was to be graphed. It would be graphed as 6.
If you were going to graph this, and I cannot stress this enough, we are not graphing. We'd put like height on one axis and time on the other, and this would be something like that. This is where it would be at 1 second, just a little bit off the top of the building, and then here's where it would be at 6 seconds, almost on the ground, if you were going to graph it, which we're not. But that's what the squared does. The squared makes it curved like that. Really, probably this is too flat. Probably it should be like this. That's probably a little more accurate. The point is it picks up speed as it drops. Gravity makes it go faster and faster and faster until it either hits the ground or reaches terminal velocity, which is the fastest it could possibly fall. Gravity's not infinite. It won't keep pulling on it forever. Cool. All right. There's your crash course in what a polynomial is. Now let's get to what we were actually going to do, which is add and subtract them. Now that you've learned the basics, let's get to the point here. We want to add and subtract polynomials. So adding and subtracting polynomials at its heart is basically just combining like terms.
On the final, will you have like where we have the say there's like a monomial?
Most likely you'll have at least one question that's like classified as polynomial. On the final, you should expect like one of every question that we've done, and not two of them, because otherwise your final would be 900 questions long. Although, who's up for a 900 question final? The first ever 24-hour final. We can make history, you guys. Who's with me?
I mean, if we all fail, will you give us all A's just for
Just for doing a 24-hour final? I cannot believe nobody's interested in 24 hours of nonstop math. Okay. So when you are adding or subtracting polynomials, what you are doing is combining like terms. Now this is one of the reasons why we spent so long talking about the degrees of a polynomial. In order to be able to say that polynomials are like terms, or have like terms, they must all be the same degree, and they must all have the same variable. So as you can see, both of these terms, negative 3x and positive 7x, they both have the same variable, which is x. Are they both the same degree? Yes, which is 1. So I am allowed to combine them because they are the same variable with the same degree. How do I combine them? Well, here's where the numerical coefficient comes in. You combine the numerical coefficients. So whatever my answer is, it's going to be something x. And the reason it's going to be something x is because that was all the terms in the polynomial. My answer is going to be x because I was adding x's. How many x's though? Well, let's look at the numerical coefficient. I had a negative 3 and a positive 7. When I combine negative 3 and positive 7, what do I get? 4. There it is. 7 minus 3 or negative 3 plus 7, either way is fine. Okay. Okay, what about those?
These are different.
What do you mean they're different?
They're just one square.
The variables are the same. They're both x's.
But the degree is different.
But the degrees are different. So those are not like terms. So these cannot be combined. So these are not like terms.
So would that be the answer?
That's the answer. X plus 3x squared. I can't do any better than that. They're not like terms. Sorry. Okay. 9x cubed plus x cubed. Those are the same variable. They're both x. And they are the same degree. They are both
6 degrees.
no.
Third.
They're both third degree. Good.
So yeah, you can.
So yes, I can combine them. I combine them by combining the numerical coefficients, which are 9 and 1. So my answer is going to be x cubed. 10x cubed. Good.
There's only 2 like terms in the second degree.
Okay, good. So we got a couple of like terms here and here. Those are both second degree and they both have x, so let's combine those. It's going to be something x squared. 13 x squared. But then look at what's left. Plus 5 and minus 7. We can combine those, can't we?
Yeah.
What is positive 5 and negative 7 combined? Negative 2. If you had to guess what the most common mistake is when combining polynomials, what would your guess be? The most common mistake?
Negative and positive.
Be more specific.
In the order you get them done.
I would say you're giving those numbers on top.
If I had $1 For every time somebody did a problem like this and wrote 13x to the fourth,
Oh, they added.
I would have like $19. I would have enough for 2 foot-long sandwiches at Subway, maybe 3 if I got something cheap like the turkey. So do not change the variable or the degree. If you are adding second degree together, your answer is second degree. Don't change the variable. This is one of the reasons why we are spending one entire day doing just adding and subtracting, because when you do multiplying and dividing, the variables do change.
Oh gosh.
So I want you to get used to adding and subtracting on its own. The variables don't change. That is a common mistake, and it gets even more common after you learn multiplying, because when you multiply, they do change. So I guess what I'm saying is next week it's gonna get crazy. Yep, that's what I was gonna say. It's gonna get crunk, as the kids say. Next week is gonna be
You're
lit.
still going? Come on.
Still going with my hip kid slang, or still going with this insanely long problem?
It's just 0.
They all combine and cancel out, and it's 0. You wish. All right. So what do we got that's like?
The fours.
Yeah, we've got some stuff to the fourth.
You've got 2 4s.
Couple of threes.
And you got 2.
There's our 4s. And we've got some 3s. Our poor little 2, he doesn't have any friends. That's all right. Okay, well, let's put your fraction skills to the test. The x to the fourths can obviously be combined because they're both x to the fourth. What's 2 fifths plus 1/10?
15.
20.
Oh, this is about to be upsetting.
35. Oh, yeah.
1/5.
1/2.
We can add the polynomials, but it's the fractions. We can't do it.
Make them like terms.
What's the common denominator of 2 fifths and 1/10?
2
Tenths.
tenths.
Hey, good news. This one's already tenths. What's 2 fifths in tenths?
Oh, 4
4 tenths. So what's 4 tenths plus 1/10?
5.
And 5 tenths reduces to what?
1/2.
1/2. You're a genius. I'll reduce it in a second.
You made me think that I was wrong.
I didn't even say anything.
Exactly.
Competence, dude.
Yeah,
Competence.
5 tenths. Why didn't you-
All right, what about these? 2/3 and 1/6. What's the common denominator there?
6.
6. This one's already sixth. So what is 2/3 in sixth?
Is 4/6.
4/6. So what's 4/6 minus 1/6?
Equals 3/6.
Positive 3/6. That'll also reduce. So there it is, unreduced.
Yeah. Next.
These are all reduced to a half, though. 1/2 x to the fourth plus 1/2 x to the third minus x squared. Next. Help me solve this. He's all like, thank you, next. Right, teens?
Sure.
All right. All right, I'm ready to hear some deep thoughts. Good, not quite as deep as I was going for, but yes, there are some x's and y's. Huh? I can't do what? Is there anything else in this problem that has x squared? So this guy's all by himself. Is there anything else in the problem that has y squared? So that guy's all by himself. Is there anything else that has an xy?
Yes.
Yes.
Why did you do the one with the y-axis?
To confuse you. It's
It's
multiplication. Order doesn't matter. XY and YX are the same thing. They can be combined.
But not in the-
What are the variables? X and Y. What are the degrees?
Second.
Second degree. They're the same. I can combine them. They're both second degrees with an X and a Y. So these can be combined.
So that would make you-
Don't give me that disgusted look. You knew what you were getting into when you signed up for this class. So the negative 9x squared is going to stay put, and the minus 5y squared is going to stay put, but the other two can be combined. What's 3xy and 7xy?
Equals 10
10
x1.
xy. The end.
Or YX.
Or yx if you're nasty. I wrote yx, everybody got mad. I wasn't going to write it again, for God's sake.
Everybody saw that one y-axis.
They saw the one yx and they're like, I'm out. College is not for me. I've decided to move to the hills and become a shepherd. All right, let's get crazy. Let's get crazy. In the words of Gandhi, I'll get crazy if I don't go crazy tonight. So I'll go crazy if I don't go crazy tonight? That's probably it. Okay, so this is an example of adding some polynomials, obviously, because there is an addition sign in between them. When I have an addition sign in between two polynomials, do the parentheses matter?
No.
No, because the number out in front of these parentheses is a positive 1. If I distribute a positive 1, nothing changes about that set of parentheses. Multiplying by 1 makes them exactly the same. So I can rewrite this without the parentheses. The parentheses don't make a difference. So maybe you're thinking to yourself, Taylor, you idiot, why'd you even write the parentheses? And it's because I want you to see the difference between adding and subtracting. When you add, the parentheses make no difference. When you subtract, they make a big difference. So before you erase parentheses, make sure that it's an addition problem. Cool. Now that I have done that, I can combine some stuff probably. Do I have any like terms here? I got lots of stuff with x and y in them, and they're all fourth degree, but what's different about this term as compared to the one right next to it? Yeah, this one the x is cubed and the y is not. Here the y is cubed and the x is not. So I can't combine these.
But you can with the
But what about this? All right, let's put those together. What's 7x cubed y and 6x cubed y? 13 x cubed y. What else can I combine? Yeah, how about the 11 and the minus 4? What is that when I combine them? Positive 7. And then I'm sorry to say our little xy cubed, no friends. Poor guy. And there it is. Hey, that's not bad. I could almost live with that. All we're doing is adding and subtracting. Next week we will multiply and divide, and you will all leave in a foul mood. I mean, worse than usual. Huh?
I'll say myself, I better be happy that.
You better be happy. Well, I'm afraid I've set you up for failure. Okay. In this problem, do the parentheses matter? They do not because
everything's added.
it's addition. Okay. So I can drop the parentheses. They do not make a difference. Man, my stomach is growling. Who brought food for the teacher?
We were going to bring you some fries, but I forgot which one.
You were going to bring me some fries, but instead you brought me nothing except
Actually, they're in the
the image of fries in my head. Thank you very much. I appreciate that.
Who had the homework with the cranberry walnut?
Yeah, who was supposed to bring me the cranberry walnut muffins?
I don't know anything about
Pretty
that.
sure that was you. Dang, I totally forgot about. I had completely forgot about that. I completely forgot about that, but now that I'm reminded, I'm pissed.
I guess she fell since.
Yeah, see you next semester, punk. All right, what can we combine here?
A's and B's.
Could you be more specific? A's and B's, yes.
You should just write it out. Throw me off.
Yeah, how about the 2A and the A?
Yeah, 2A and B.
They're both positive, right? So let's just put them together. What's 2A plus A?
3A.
3A. Cool. What else? The 2B's, or not 2B's. Yeah, no B's. Negative B plus B is 0B. I could write 0B if I wanted to, I guess. You don't really have to. Doesn't make a lot of sense to write 0B, but you can go your own way. Now what? Yeah, what about the -5 and the +5?
They cancel out.
That's also going to be a 0. And then our poor little 3A cubed at the beginning's got nothing. So my actual answer is going to be the 3A cubed at the beginning, the positive 3A that I got from combining stuff, and that's it. I don't need to write the zeros. In fact, it'd be kind of weird if I did. Kind of weird if I did. That's all there is to addition. Addition's pretty simple. You drop the parentheses and then combine like terms.
So how happens with subtraction?
That is such a good question.
Is all the variables
That was all together.
that was just addition, right?
That was just addition. Let me show you a subtraction one since you asked so nicely.
Are we getting rid of the variables?
No, we're keeping the variables pretty simple tonight. I told you next week is the one where I'm going to ruin your life.
So don't punish it.
Next week would be a bad one to skip. Because we're going to learn not only a bunch of stuff, but a bunch of stuff that carries over into the next class. So I don't recommend missing next week's class. Now, if your choices are either miss next week's class or come empty-handed without a cranberry walnut muffin, I mean,
Can I just bring food?
what, like drop off food and then go home?
Yeah.
Here's some muffins. See you later.
Have a nice class. Have a nice class.
All right, so here I can't just drop the parentheses. Now I can just drop the parentheses on the first one because the thing out in front of the first set of parentheses is a 1. And if I'm distributing a 1, nothing changes. So the first set of parentheses is fine. It's the second set of parentheses that is a problem. This subtraction sign means subtract all of this stuff. I have to subtract all three things. I have to subtract the 2x cubed, I have to subtract the negative x squared, and I have to subtract the 1. So the first part's easy. Minus 2x cubed, simple. Here's where it gets a little tricky. Minus negative x squared.
That just makes it a positive.
So plus x
Whoa, whoa, whoa,
squared.
whoa, whoa.
You know why, right?
Wait, why did you?
Why?
Because you're.
It was a negative multiplied by a negative,
I
which
thought
is
we're
positive.
subtracting.
We are,
You're just
but this,
multiplying.
I am because of these parentheses. There's a -1 out in front of the parentheses that says to subtract all of these.
Oh, that's gonna get me.
Yep, I told you it's tricky. And then -1. That's the hard part because now that we've done that, we're back to an addition problem where you're just combining like terms. What do we have here that can combine? Okay, so yeah, there's a 2x cubed and a minus 2x cubed. That's gone. I'm not even going to write the 0 this time now that you've seen it disappears. What else you got?
We got the 8x cubed and
Uh,
10 cubed.
You mean squared?
Squared.
8x squared.
9x squared.
That's good. That's 9x squared.
And then minus.
And that's it, because the
6x
6x and the 1 can't combine. And there we go. I want you to notice how much easier it is to make sure we've done everything whenever you mark in some way the things you're combining. Like I'm using different colors to highlight each pair of like terms. If you don't want to use different colors or highlighters, you could maybe circle or square or whatever the things as you combine them, so that in some way when you get to the end, you know you've gotten everything. When you get these really long problems, sometimes it's easy to leave something behind. Like, oh, I forgot to combine this. Let's do another one of these. Whoo, yeah! Now that's a good problem. That's pretty much the longest they get. We try not to do too many that are worse than that. Huh?
We got the b squared in front of the a.
Just take a minute and bask in the glory of this problem. It's really good. What makes it not good? You know, I need a little more positive attitude from you people. Your negativity is really bringing the class down right now. Can I just drop the parentheses?
No.
I mean, kinda.
Or just the
first
Right, I can drop the first half because there's nothing out in front of the parentheses, or there's a 1 out in front of the parentheses. So I'm just going to rewrite that without the parentheses. Okay. The second set of parentheses I cannot just drop because this minus sign is saying subtract all of this stuff. So what's that going to look like? Walk me through it.
Positive negative,
So 5b squared a.
and then the positive 2 will be now a negative.
Right, so
2ab.
minus 2ab.
Now the 3 will now be a positive.
Good, it's minus negative 3 plus 3.
Plus the 9b squared. Change it.
Only 2 of them can be combined.
Yeah, what do we got that can be combined?
B squared.
Huh?
B squared.
I see this has a b squared and that's it.
No, it's AB and then.
That one's got an a with it. There's an ab squared, but there's no more just plain b squareds.
We got the 6ab and the negative 2ab.
Okay, there we go. What's that when I combine them?
4AB.
All right, what else you got?
Let's see.
Oh, I disagree.
Can you do the 9a squared plus b, or the 9a squared b squared, and then the 5a squared?
No, because the 5 just has a, not a squared.
Oh, negative 3ab squared and 9b squared?
No, because the 9 doesn't have an a.
The negative 3AB squared and the negative 5.
There we go. You guys are so easy to trick with the order. It's multiplication. The order doesn't matter. Those both have an a and a b squared. I can combine those. Making a note here. It's going to be definitely doing that on your final now. What's that when I combine them?
G thanks.
No, g thanks is not what I get when I combine them.
Negative 8
Negative 8.
ab squared.
There we go. Now, none of the rest of this can be combined. These two can't be combined because although they both have b squared, only one of them has a squared and the other one doesn't. And then 3, poor guy's got nothing, can't combine him with anything. So the rest of the problem is just what's left over. Positive 9a squared b squared, a positive 3, and a positive 9b squared.
I have a question.
Okay?
When you finish bringing everything down, do you just go from there to there, or do you put them all?
Each of them all.
If I was a really good mathematician, I would put them in order from largest degree to smallest. Real mathematicians would be cringing that I'm not doing that. It's not that big of a deal. It's just typically that's how you write them. So that's a 4th degree. That would come first. After that, we have a 3rd degree. Then would be the 2nd degree. We've got 2 2nd degree polynomials. The 4ab and the 9b squared are both, so it doesn't really matter which is which. And then
What
plus
will the
3.
computer do to us when we try to-
It won't matter. The order doesn't matter. It's correct no matter what. But this is like if you were at a math symposium on polynomials. You know, as you are on occasion.
Yeah, I felt like it.
Okay, let's do one more of these. Let's see if I can mess you up.
Is it gonna be a long one again?
Not as long. It's gonna be a long one again. I don't know, you gonna whine about it again?
Oh, because I was gonna turn my page.
Well, the first 2 you can drop your parentheses, right?
Very good. The first 2 can have the parentheses dropped because there's only there's either nothing in front of it or there's a positive in front of it. So no reason to keep those parentheses going. Good. Minus 5z. And then minus negative 7 is plus 7. Yeah, we've got 3 z's this time. Or not 3z. What's 8 plus 9 minus 5 all combined? 12. Okay. And then we've got some numbers, right? Plus 11, minus 2, plus 7. I heard 2 different answers. 16. And these last 2 are really the worst they get. They're either going to be gigantic, where there's a bunch of stuff to combine, or they're going to be less gigantic, but have both plus and minus in the same problem. That's really the worst that they get. Any questions about the last one?